we're here to look at a special device that connects to the end of the motor of this old Schindler lift. But this wouldn't be a Mr. Matt and Mr. Chay video without the usual attention to detail, and there's a few devices that I'd like to examine. This is an old lift installed in 1969. Let's get straight up to the motor room on the top floor. First, a couple of runs up and down, but it's the sound of the motor that I'd like you to listen to. It gives you a clue to what the device does on the end of the motor. That noise is George turning the switch that switches the lift from normal to inspection mode. Oh, and this old lift has character. It gets excited for a second or so each time a run has completed. This is the device. Let's watch it in action, and again, please pay attention to the sound of the motor in the background. The motor has two acceleration sounds. When an AC motor is not spinning, connecting it straight to power will demand too much current. The motor windings must be set to a special start configuration before it can be allowed to reach full speed. This is known as start delta, and here is a quick explanation. Around a motor are windings which connect to a three-phase main supply. The AC sine wave makes it spin. To start a motor, these windings are connected in this star configuration. P1, P2, P3 are the electrical connections from each phase. The star arrangement prevents overloading the electrical supply when power is connected to a motor that isn't already spinning. This configuration only demands about a third of the power. Once the motor is spinning, the configuration is changed via relays or contactors to this delta configuration. The phases now connect directly to the motor windings, and the motor now accelerates to full speed. The windings do not physically move like in this animation. This is simply to show you how the relays in the cabinet change the electrical connections to the motor. The conclusion is, star delta is very important to get an AC motor turning. Short lesson over. The device at the end of the motor is called a velocity sensor, speed sensor, or you could just call it a speed switch. Here's one in action from a different lift. Although it's a different design, The mechanical principle is still the same. The speed switch spins around with the motor. I'm showing it static here. When it spins above a predetermined speed, the switch inside creates a circuit. The circuit has to reach the control cabinet, and because the switch is spinning, it uses these copper tracks around the edge to make an electrical connection to the contacts on the sides. One side of the switch connects to the inner ring, and the other side connects to the outer ring. And here is the path from the switch to the cabinet. The contacts on the right duplicate the contacts on the left and are just a backup. For this animation, I'll focus on the contacts on the left. To demonstrate its operation, George will lift the connections away from the rings on one side of the switch so that the motor cannot switch to delta. Instead, the motor will stay in the star configuration. When the speed switch is able to form the circuit, the motor switches to delta and you'll hear the motor spin up to its full running speed. Other lift manufacturers used a timer. The advantage of using a speed switch is the transition from star to delta happens when the motor is spinning fast enough and at the optimal speed. I'm not ending the video here. Multi-cam reviews are coming up. And in particular, I'd like to have a closer look at this device. Before the 1970s, most timers were mechanical, which is exactly what this is. The timer is set when the lift runs, then it starts timing a few seconds after the lift has stopped. This few seconds comes from another timer connected to the brake, which you'll see in a moment. The contacts at the bottom, two of them set the timer to the mechanical stop, to which this timer is set to 30 seconds. These timers look quite expensive, but it's devices like this that give these old lifts character. Nowadays, a cheap electronic timer will do the job at a fraction of the cost. This timer turns off the cabin lights and other things like transformers when the lift is not in use. The terminals marked 1 and 2 break a circuit when the time runs out, and you may notice a short spark when this happens. Now we come to the door timer, and I'm guessing that using one of these large timers was a bit over the top just to time a few seconds. So Schindler made a cheaper one, linking it to the brake. At the top is the classic Schindler motorized brake, and to the right of it you can see a lever. When the lift brake is applied, you'll notice this lever raise under the control of an air chamber, which slows it down. The door timer stops the lift from moving for just a few seconds for passengers to open the outer doors, before the switch triggers the next journey, if there is one. Here it is in action, and you'll notice there's a few floors selected inside the lift car. To my viewers, I hope I've done enough for you to consider subscribing to the Mr. Matt and Mr. Chay channel, and thank you very much for watching.